Hello. We have previously discussed the measures of central tendency, which is an important statistic of data. Spread is another important statistic of data. Different data sets usually have different variations. In this video, we focus on the concepts of range and quartiles. In Module 3, we will also discuss other variations measures, such as variance and standard deviation. The range is the simplest measure of variation. The value of range is given by the maximum value minus the minimum value. For example, in this given data set, the highest value is 13, and the lowest value is 1. Thus, the range is equal to 13 minus 1 equal to 12. The biggest issue of range is that it ignores the distribution of data. For example, in these two data sets, we get the same range of 5, which is given by 12 minus 7. However, the first data set is more evenly distributed, whereas the second data is heavily left skewed. The second issue of range is that it is sensitive to outliers. For example, the following two data sets are almost the same except the last item. The first data set has the highest value of 5, whereas the second data set has the highest value of 120. As a result, the range of the first data set is only 4 equal to 5 minus 1, but the second one is 119 equal to 120 minus 1, although almost all the other data are identical. Therefore, if there are extreme values like that in the second data set, we should be cautious of using range as the measure of variation. Different from using only the highest and the lowest values to measure the spread, a more subtle approach is to examine the quartiles. To measure quartiles, we equally split the sorted data into 4 segments. In other words, each segment has 25% of data. The first quartile is at the 25% quartile point. The second quartile is in the middle of the data. And the third quartile is the 75% point. The second quartile is also called Q2, is the same as the median. That is, 50% of the data are smaller and 50% are larger than the second quartile point. Because the exact point of 25%, 50%, and 75% quartiles are not guaranteed to be integers. There's no universally correct way to calculate the quartiles in a data set. For example, if we have only 5 observations in the data set, it is not straightforward to identify the quartiles. In fact, different statistical software might use different formulas to calculate quartiles. So we should be aware that the final quartiles values might be different, even though close, under different software. In the following, we will introduce an approach to calculate quartiles, which is different from that used in Excel. But when the numbers of observations in a data set is big enough, typically the values of quartiles are very close among those different calculation approaches. Throughout this course, please use this approach taught in this video to calculate the quartiles to be consistent. We hereby demonstrate how to calculate the quartiles and percentiles using the following data set: 74, 73, 77, 77, 71, 68, 65, 77, 67, 66. Suppose we are going to find the third quartile and the 60th percentile. The first step is to sort all these observations in an ascending order as follows: 65, 66, 67, and so on. The second step is to calculate the index by multiplying the percentile with the total number of observations. If the resulting index is an integer, we will use the average of the values of the index and the next, that is, index plus 1, sorted observations. If it is not an integer, then we round up to the next integer to obtain the index value, and then use the persistence observation as the percentile. In this specific example, computing the index of the third quartile leads to 75% times 10 equal to 70.5, which is then rounded to 8. And the eighth value of the sorted data set is 77. So the third quartile, or Q3, equal to 77. We can use the same procedure to obtain other percentiles. For example, for the 60th percentile, the index value is equal to 60 times 10 equal to 6, which is an integer. So the 6th percentile is given by the average of the 6th, and the 6 plus 1 equal 7th values, which is given by the sum of 73 and 74 divided by 2 equals to 73.5. After obtaining first and third quartiles, we can then use the range of these two quartiles to measure the spread. Specifically, we define the interquartile range, abbreviated as IQR, as the range of the third quartile minus the first quartile. IQR is also referred to as the mid-spread because it covers the middle 50% of the data. Compared to the range, the advantage of IQR lies at its interdependence of the outlier. Because the measure of the quartile and IQR are not influenced by outliers, we also call them resistant measures. We can also use the quartiles to help describe the data in this 5-number summary. In specific, the 5 numbers are the smallest value of the data, the first quartile, the median, the third quartile, and the largest value of the data. In this way, there are 25% of the data in each segment. However, this 5-number summary cannot prevent the impact of the outliers because all outliers are included in either the bottom 25% or the top 25% of the data. To minimize the impact of outliers on describing the spread, we thus introduce another tool called the box and whiskers plot. In the box and whiskers plot, we continue to use the first quartile, the second quartile, the third quartile. However, we replace the lowest and the highest value with 2 sets of fences. The first set of fences are called inner fences, which is defined to be located 1.5 IQR away from the quartiles. More specifically, the lower inner fence is given by Q1 minus 1.5 times IQR. And the upper inner fence is given by Q3 plus 1.5 times IQR. So this is the lower fence, inner fence, and this is the upper inner fence. The second fence is called outer fences, which is called located. The second fences are called outer fences, which is located. The lower inner fence is given by Q1 minus 3 times IQR. And the upper inner fence is given by Q3 plus 3 times IQR. As demonstrated over here, this one is the upper outer fence, and This one is the lower outer fence. The box and whiskers plot can be placed either vertically and horizontally. Based on the information of inner and outer fences, we can then draw dashes lines from the first quartile to the smallest measurement. That is the observation with the smallest value above the lower inner fence. And from the third quartile to the largest measurement below the upper inner fence. These two dashes lines are called whiskers. The area between the lower quartile Q1 and the upper quartile Q3 is called the box. The range of the box is equal to the IQR. So far, we have used the concept of outliers and extremes values alternatively. In our daily life, people are using them alternative too, although people may argue that the extreme values should be those at the boundary, and extremes are special outliers. In definition of the box and whiskers plot, we also try to differentiate the extremes from outliers. Here, we further define those observations between the inner fences and outer fences as outliers. Those observations outside the outer fences are further referred to extreme values. Let's demonstrate in another graph over here. As we can see from this graph, we have the box defined by the first quartile and the third quartile. We also have the inner fences and outer fences. The left and the right whiskers are defined from Q1 to the left lowest point and Q3 to the right highest point within the inner fences. The outliers are those between inner fences and outer fences. And extreme points are those outside the outer fences. So in this way, we can further differentiate those extremes from outliers. In this video, we have defined what are range and quartiles. We have also learned how to compute and interpret percentiles, quartiles, and box and whiskers plots. Based on the box and whiskers plot, we can further define outliers and extremes in a more subtle way. This concludes this video. Thank you.